So now let's talk about our main topic, which is profit maximization process. When we are going to maximize our profit, there are two steps. There are two steps for our profit maximization. So we can obtain from two sequential steps. The first one, when we have our output, our y, which this y is a function of like our input. When we have y as a function of our input, or y is equal to f of x, then by having this function and by having our cost, which is equal to w multiplied by x, when we have this two function or two value, y is equal to f of x and c is equal to wx, when we have this one, then by getting the optimal value from this two step, which is like called cost minimization, we will talk about later on. By using cost minimization process, when we have this two value, then we will get our input choice, and also our input choice at the minimum level of our cost. But this time, our input demon function is conditional factor demon function. Now it's not unconditional. Because in this process, because here we have y, here we have y is equal to f of x, then when we are going to minimize our cost, when we are going to the cost minimization process, then we will get some value for our x, which this x is some function of input price and output level. Input price and output level. So when this is a function of input price and output level, which is input is w and output is y, then it's called conditional factor demon. And then when we add the value of this conditional factor demon to this cost instead of x, then we will have c w multiplied by z as a function of w and y. Then we will have our cost as a function of w and y. So that's why by using the first step, when we have y is equal to fx and c is equal to wx, when we do the cost minimization process, then we will get the conditional factor demand, which is equal to z as a function of w and y. Either you can write down just equal to x. It doesn't matter. You can write down x, you can write down z. But we write down this one z because to differentiate this one from our unconditional demand function. Because in unconditional demand function, we just simply write down x is equal to as a function of p and w. But we use different notation z in order to differentiate these two functions, conditional and unconditional. So when we have conditional factor demand function, just add the value instead of x to in cost, then we will have our cost as a function of input prices and output level, which this one is called simple cost function. And usually in our mathematical example, we have cost as a function of w and y, not as a function of p. So then, at the next step, when we have our cost function, because our pi is equal to revenue minus cost, and this revenue itself is equal to p multiplied by y, minus now our cost is also as a function of w and y, so it makes easier to maximize this profit. Because now instead of before, we have we have written instead of C, WX. But now we don't need to write WX. We just simply write down the cost function itself, which is a function of W and Y. So now PY, C as a function of W and Y. So we have our output level, we have prices, we have input. So basically, it's easier to maximize our profit when we have this type of profit function. Why? Because in a perfect competitive market, you know that the price of output and the price of input are given. So based on that one, we are maximizing, or we try to find out the optimal level of output to maximize our profit. So that makes it easier. So there's two steps. First one, we do the cost minimization to find out our conditional factor demand and cost function. Then we plug the value of the cost into profit function to find out our profit maximizing output level. So step one, when we like think about that, our input market is a competitive market. Our input is a competitive market. Why? Because here you see that X is a function of input price and Y. So when the input price is given, it means our input market is a competitive market. But in the second step, as you see here, we have P. When you see the first step, we have W, there's no P. So it means our input market is competitive market. But in the second step, when you see the profit function, we have P as a price, as an output price. It means when we do the second step, we impose the competitive assumption on our output market, because the P is the output price, not the input price. So this is the two step. So let's do it step by step to maximize our profit. First of all, as I said before, the first step is that when we have our Y, which is some function of input, and when we have our cost, which is equal to WX, when we do the cost minimization process, it leads us to this two value. X is equal to Z as a function of input price and output level, and C as a function of input prices and output level. So let's do it, how we can find it. So actually this cost is the minimum cost level of producing optimal level of output. Is the minimum cost level of producing optimal level of output. So then we are going to minimize this one. Which one? We are going to minimize our cost in order to get the minimum level of our cost to produce optimal level. So then when we are going to minimize this one with respect to X, with respect to input, we have a constraint, and that constraint is this one, our output or our production function. So here, then it's such that f of X, which is our production function, is greater than and equal to our output level. So what does it mean? It means when we are combining some input, we want to at least produce some Y level of output, not less than that, or either at least equal to that or greater than to that. We don't want to produce less than that. So that's why it's such that f of X greater than equal to Y. But we mostly impose equality if our X is greater than 0. So then when we have this function, we simply can use the Lagrangian approach to minimize our cost, or to find out the conditional demand function and our cost function as a function of input price and output level. So just we simply write down our Lagrangian, which is this Lagrangian is equal to W multiplied by X plus lambda multiplied by Y minus f of X. minus f of x. Then we are going to find out the first order condition. And when our x is any input function, any input demand function, if it's greater than 0, we impose equality here, this equality, instead of this greater than and equal to. So then, when we take the partial derivative of this Lagrangian function with respect to our input level, because we are going to minimize on our objective variable, which is x, our choice variable is x. So then we are taking the partial derivative of lambda, this Lagrangian with respect to x, and it will be equal to this w minus lambda multiplied by the partial derivative of f of x with respect to x. Because here we have y, so then the partial derivative of y with respect to x will be 0. So then we will have this one, and it's equal to 0. Is equal to 0. Then finally, our w, which is our input price, will be equal to lambda multiplied by partial derivative of our production function with respect to x. So this is the first order condition. So we have greater than and equal to here, but still when we are thinking about our x, this x, which is greater than 0, then we impose that there is inequality exists. But as we know that this w is what? This w is a vector. And x is also as a vector. So it can be any x, x1, x2, x3, up to xl. So it's better to write down this one as a partial derivative of Lagrangian with respect to some L. And this is also the input price for our L input. This is the input price for our L input. This is the input value of our L input. So now suppose that we have only 2 inputs. When we have only 2 inputs, then our production function f of x, which is x is a vector, then it will change to this one, f of x1, x2. F of x1, x2. Now we have this kind of production function, because now x is a vector of x1 and x2. So then, what will be the change here? Then we have 2 first order conditions. One first order condition for x1, another first order condition for x2. So overall, we can write down this one, WL greater than and equal to lambda, which is our Lagrangian multiplier, multiplied by the partial derivative of f of x with respect to xl. But we now know that if we write down WL is equal to some lambda multiplied by partial derivative of f of x1, x2 with respect to xl. So now this L is equal to 1 and 2. This L is equal to some value of 1 and 2. So then we can change it to 2 different equations. So we can write down W1 is equal to lambda multiplied by the partial derivative of our production function with respect to x1. Then we can write down W2 is equal to lambda multiplied by the partial derivative of our production function with respect to x2. So we have 2 equations now, equation 1 and equation 2. So now we have 2 equations, and also when we are taking the partial derivative of our Lagrangian, the partial derivative of our Lagrangian, so we have one partial derivative for x, and also here when we are talking about Lagrangian, then in Lagrangian we have two choice variable, which is our x and lambda. Yeah, which is x and lambda. So now when we are taking the partial derivative of our Lagrangian with respect to lambda, then it will move to this value. So now just take the partial derivative of with respect to lambda. We will have y minus f of x. We will have y minus f of x equal to 0. And if x is x1 and x2, then this one we will have y is equal to f of x. And then if x is x1 and x2, then we will have y is equal to f of x1 and x2. So now, as you see, we have 1, 2, and this one is 3. This one is 3. In order to maximize our profit, divide equation 1 to equation 2. 1 divided by 2. Then when we divide 1 by 2, then we will have W1 divided by W2 is equal to, then when we divide both sides, so this lambda will cancel out with this lambda, we will remain with this one. The partial derivative of our production function x1 and x2 with respect to x1, and the partial derivative of our production function x1, x2 with respect to x2. So now we come up with one like very familiar equation, which is W1 over W2, which is this one is our input price ratio. This one is our input price ratio. And this one, the partial derivative of production function with respect to x1 divided by the partial derivative of production function with respect to x2 will give us a very familiar term in producer theory. What will be that? Can you guess? So when we take the partial derivative of production function with respect to x1, what will be the result? Marginal product of x1. Yeah. So then it will give us the marginal product of x1. And when we take the partial derivative of production function with respect to x2, it will give us the marginal product of x2. But when we divide the marginal product of x1 to marginal product of x2, it will give us a very familiar term in producer theory, which is marginal rate of technical substitution. If you remember, when we define marginal rate of technical substitution, this marginal rate of technical substitution is equal to the partial derivative of our production function with respect to x1 divided by the partial derivative of our production function with respect to x2, and it will be equal to the marginal product of x1 divided by the marginal product of x2. And finally, we move to this equation, which is marginal rate of technical substitution is equal to the input price ratio, or simply our marginal productivity ratio MPX1 divided by MPX2 is equal to W1 divided by W2. So when we have, so this one, so let's consider this one as equation number 4. Equation number 4. And we have here this one, equation number 3. Now consider equation number 3 and equation number 4. So when we have two equations, which is one is this one, which is equation number 4, and one is this one, which is equation number 3. This one is our equation number 3. This one is equation number 4. So now we have two equations and two unknown, because this y is equal to f of x1 and x2. So when we think about two input, so it means we have two unknown, x1 and x2, and we have two equation, equation number 4 and equation number 3. So when we have two equation and two unknown, and if the first order condition is satisfied, it means when there is no corner solution. So when there is corner solution, we cannot use this way, because in corner solution, when we have the corner solution, simply this one will change to like some constant value. When we think about like linear production function or perfect substitute production function, which there is a corner solution, if you remember in case of utility maximization, when there was corner solution, so we couldn't use Lagrangian. But when there is no corner solution, so now we have two equations and two unknown, we simply can find out our optimal conditional input demand function. How? So it's simply what we are going to do from the equation number 4. From the equation number 4, from this equation, we try to find out x1 or either x2, x1 or either x2 in terms of x2 and also w1 and w2. Let me write down again, x1 as some value of x2, w1 and w2. So now what we are going to next, when our x is in terms of x2, w1 and w2, then in this function, and instead of x1, we write down this value. And instead of x1, we write down this value. So here, then y will be just simply as a function of one choice variable. So then, when we add the value of x1 in terms of x2, w1 and w2 here, then we can simply find out x2 optimal bundle, which we can write down as a z2, as a function of input price and output level. Why? Because x1, as you see here, x1 is a function of w1 and w2. And also here we have another y term. Then when we add, and instead of x1, x2, w1, w2 as a value here, then here we have three things. We have y here, and in this part of the function, we will have w1, we will have w2, and also we will have x2. Yeah? Then when we find out the value of x2, so then x2 will be some value equal to y, w, and w2 as a function. So then x2 is a function of w and y. Or if we have two input, then this x2 optimal demand function for input 2 will be equal to as a function of w1, w2, and our output level. So then, when we have this x2 value here, what we are going to do next, so let me use some different color. So now we have our optimal level of demand for x2, yes, which is a function of w1, w2, and y. Then we have x1 here as a function of like some x2, w1, and w2. Then add this value of x2 here, and instead of x2, write down this value, which is W1 as a function of W1, W2, and Y, right down here, then this X's also will become X1 star, also will become some function of W1, W2, and Y. Why is this? Because when we add instead of X's value, which is a function of W1, W2, and Y, here also we have W1 and W2. So finally, this X1 is as a function of this W1, this W2, this one, and this one. And also, because we don't have anymore the X2, and instead we have Y, because we add the value of X2 here, then our X1 star is also as a function of W1, W2, and Y. So then, this one is our optimal demon function for X1, and this one is our optimal demon function for X2. Our optimal demon function for X2. And later on, so finally we will have like our X, when we write down in terms of vector, this X star, which is optimal level of input demand, but here is conditional. Why is conditional? Because it's conditional on our output level. We have our output here. So then X star is some function of W and Y. We write down by Z just to differentiate from the unconditional demand function. As W is vector, and this one X is also as a vector, so we can write down this one as a vector, which is Z1 as a function of W and Y, up to ZH as a function of W and Y. But when we have only two input, then we have as a vector of only two function, which is Z1 as a function of W1, W2, and Y, and we have Z2 as a function of W1, W2, and Y. So when we have only two input, we have a vector of only two elements, because we have only two factor demand function. And finally, when we add this factor demand function in our cost, then we will have our cost function. We already know that our cost is equal to W multiplied by X. W multiplied by X. But now we know that the optimal level of X, optimal value of X, which is some function of W and Y. So then instead we write down C equal to W multiplied by Z as a function of W and Y. So finally, as you see now, this cost is a function of W and Y, and simply we can write down cost as a function of W and Y. This cost is a function of W and Y. So now we found out two things, which is conditional demand function, which is conditional on our Y, and our cost function, which is cost as a function of output, as a function of output level. It depends on how much output we produce. If the output increase, so our cost will increase. If the output decrease, our cost would decrease. So we have done with the first step. When we were talking about the profit maximization step, we told that there's two steps. First one, we are going to find out the conditional factor demand and cost function. And in the second step, we are going to find out the profit maximizing output level.